Welcome to today's lesson on rotations and reflections. So those are the two transformations that we're focusing on today. I'm going to share my screen. Okay, so our TEK for today is 8.10c, and our lesson target is I will explain the effect of reflections and rotations on two-dimensional shapes on a coordinate plane using an algebraic representation. So first off, I want to break down the word algebraic representation. That's just a long way of saying a math rule. So we're going to learn the math rules for reflections and rotations. We have two essential questions for today. The first one is which transformations preserve congruence? And the second one is which transformations preserve orientation. So let's remind ourselves what congruence means. Congruence means same shape, same size. So out of the four transformations we've learned about, dilation, rotation, reflection, translation, we know that the ones that maintain the same shape and same size are translations because a slide does not change the shape or size. A rotation, because when you turn a shape, it does not change the shape or size. And a reflection, because when you reflect a shape, it gets flipped, but you're not changing the shape or the size. Then for the second question, which transformations preserve orientation? We have to remind ourselves that orientation is talking about the direction or the position, right? So in a translation, when you slide, the position on the coordinate plane changes, but the position of the vertices or the corners of the shape do not change. So that's why the direction or position is maintained or preserved. In a rotation, when you're turning it, the orientation does change. The only exception is for a 360-degree rotation because that's putting the shape in the same position. And then reflection, of course, when you're flipping a shape, the location of the letters or the vertices, some of them may change. So the only two transformations that preserve orientation are translation and dilation. Because even if you're making a shape bigger or smaller, the location or the direction of the vertices or the corners of the shape do not change. Okay, so our vocabulary words are very similar to what they have been for the other lessons on transformations. So we have congruence, coordinate plane, orientation, which again means direction and location, or direction and position, I guess I should say. Pre-image is the old or the original, as seen in the prefix pre. Reflection is one of our transformations we're working on today. Line of reflection, we have two. We have it highlighted in red, which is the x-axis, and highlighted in blue, which is the y-axis. And of course, rotation is our second transformation that we're learning about today. Okay, so for rotations, there are two directions that a shape can be rotated. So one of the directions, as you can see highlighted in orange, is clockwise. And then counterclockwise is highlighted in green on the right side. Then in terms of the degrees that a shape can be rotated, you can see that I've highlighted 0 degrees, 90 degrees, 180 degrees, 270 degrees, and also 360 degrees. So I wrote that on top of 0 because, again, a 360 rotation returns a shape or a point to its beginning. Before we get started with this activity, I do want to make a chart. Okay, so we know that the two directions that a shape can rotate are clockwise and counterclockwise. So we're going to make the chart. And we know that the angles that it can rotate, as previously mentioned, was 90 degrees, 180 degrees, 270 degrees, 360 degrees. And we know that all transformation rules always start off with x comma y. I don't want to have to write that for every line, so I'm going to just write it once at the top. Okay, so the special thing about a rotation is that when you rotate a shape, the x and the y are going to flip. And they're only going to flip, though, for 90 degrees as well as 270 degrees. 180 degrees and 360 degrees, it still maintains the x comma y. So if you look at it, it's y. Well, we start with x comma y in the beginning, right? Then it's y comma x, then x comma y comma x comma y. Okay, then when we put a negative here, we don't necessarily mean that the number is negative, but that the sign changes, that it changes signs, right? So I like to say the phrase or the saying, a soldier goes right, a soldier goes right, left, right, left. So that's where you add the negative. And again, the negative does not mean the number is a negative, it just changes signs. So we'll get some examples of that in our activity for today when we're actually using numbers. And so if the shape is rotated, we can see that it's rotated at the bottom right here from triangle A to triangle A prime. That is counterclockwise, and that is 90 degrees because every time you're in a quadrant, you're rotating 90 degrees. So we went from quadrant 1 to quadrant 2. That is going to be the same thing as a clockwise rotation, which is the opposite direction of not 90 degrees, not 180 degrees, but 270 degrees. So I'm going to find clockwise of 270. That's our rule negative y comma x. And I'm going to say that's the same thing as counterclockwise of 90 degrees. Then the opposite is true, right? So I'm going to change color. If I rotated A clockwise 90, that is the same thing as rotating A counterclockwise 270. So that's why clockwise of 90 is the same thing as counterclockwise of 270. 180 and 360 are easy because a 180-degree rotation, clockwise or counterclockwise, will result in it being in the same position. So that's why 180-degree clockwise is the same thing as 180 degrees counterclockwise. And then for 360, same thing. 360 degrees clockwise is the same thing as 360 degrees counterclockwise. Okay, so now we have to fill out the rest of this chart. So 90 degrees clockwise is the same thing as 270 degrees counterclockwise, right? That's evidenced by the sides. And we know the rule for that is going to be y comma negative x. So I'm going to go ahead and write that all rules start off with x comma y, and that first rule is y comma negative x. Then for 180-degree rotation, clockwise or counterclockwise, you can see is the same. It's negative x comma y. So we're going to start off with x comma y to negative x comma negative y. Then for the next one, we have a 270-degree clockwise rotation and a 90 degrees counterclockwise rotation. We know they have the same rule, which is that negative y comma x. So I'm going to go ahead and write that in. But I'm going to start off with x comma y to negative y comma x. And lastly, the 360-degree rotation, which we know that regardless of which direction, the rule is still x comma y. So you're just staying in the same position. Okay, so now we have to answer the two sentence stems. So 90 degrees and 270 degrees rotations are the only rule that. So I'm going to go ahead and highlight. We have 90 degrees, 270 degrees, 270 degrees, 90 degrees. If we look at this rule right here, we can see that in both of them, the x and y coordinate are flipped or are switched. And if we look at the 180-degree rotation, is the only rule with both. So if I highlight that, it's this one right here, negative or opposite signs. Because again, even if it says both negatives, if the number started as negatives, it would flip to become both positives. Okay, so in terms of congruence, we already kind of spoke about this. So when you rotate a shape, it does not change shape or size. So yes, it does maintain congruence. And in terms of orientation, the only time that a rotation would maintain orientation is in a 360 rotation, but other than that, it would not maintain orientation. Okay, we're going to go on to our activity. So it says consider the point x comma y located anywhere in the first quadrant. So again, this is quadrant number 1, and then it goes 2, 3, and then 4 as a review. So the original point is at x comma y in quadrant number 1. A reflection across the x-axis. I'm going to go ahead and highlight the x-axis. So this is the x-axis. We'll take the point from being above the line of reflection to being below the line of reflection. And in that case, that means that the y-coordinate changes, right? So x stays the same, the y-coordinate changes. To show that the y-coordinate changes, we're going to put a negative sign, right? Because it went from being above to being below. But of course, if it started being below, it can flip to being above too. And then reflection across the y-axis. I'm going to go ahead and highlight the y-axis. So this is the y-axis right here. So we can see that our x comma y is to the right of the y-axis. If we flip it, it would be on the left side, right? So in that case, if we flip it, then it's the x-coordinate that changes. So we're going to have negative x comma y because the y-coordinate stays the same. So an easy way to remember the rules for reflections is that if it's reflected across the x-axis, it's the x-coordinate that stays the same. If it's reflected across the y-axis, it's the y-coordinate that stays the same. And so the other letter will flip signs or change signs. Okay, so instead of graphing, since we have the rules right here, I'm going to go ahead and use the rules to help us fill in the rest of this table. So we know that every point always starts off with x comma y, right? And then of course, when it is reflected across the x-axis, the rule becomes x comma negative y. So if we start off with a is at 3 comma 4, then a prime we know is going to be at 3 comma negative 4. Then b prime we know is going to be at 6 comma negative 1. C prime is going to be at 4 comma negative 9. So we're going to use the rule that we came up with for reflection across the y-axis, the algebraic representation. So that rule is negative x comma y. Okay, so a double prime, which is a with 2 of what we know as the apostrophes, is going to be at negative 3 comma 4. B double prime is going to be at negative 6 comma 1. And C double prime is going to be at negative 4 comma positive 9. So for now, we're going to skip past the graphing because I just want us to get a grasp and understanding of the rules. Okay, so now we're looking at this picture. Consider the 2 figures shown. And I see that it's a reflection, right? So the pre-image is the one that's on the right or grayed out. And so we know that our line of reflection is going to be this y-axis. And so we have to answer the question, is quadrilateral JKLM congruent to quadrilateral J prime, K prime, L prime, M prime? So we know that quadrilateral JKLM is congruent because in a reflection, the congruence is maintained to quadrilateral J prime, K prime, L prime, M prime, right? The shape does not change, the size does not change. Now we have to fill in this table for rotation. So we're going to use this information that we talked about earlier to fill out what we have here. So we know that, again, all points always start off with x comma y, right? And so we have to be very careful this time to look at whether it's a 90 degrees clockwise or counterclockwise, because you can see that the first one is counterclockwise, but the second one is clockwise. Okay, so for 90 degrees counterclockwise, I'm going to look over here. Counterclockwise of 90 degrees, the rule is negative y comma x. So I'm going to go ahead and write that, negative y comma x. Okay, so if we know that is the rule, then for a prime, I know I have to write my y value first, right? And that's 4. But now I know that it's going to be negative 4. And then the x is positive 3. Then for b prime, again, we're putting a negative, but our y value is 1. And then we're keeping our x value of 6. For c prime, we're putting negative 9, comma, positive 4. Okay, so now we have to do a rotation 90 degrees clockwise. So if we look over here, clockwise of 90 degrees, the rule is y, comma, negative x. Okay, so a double prime this time is going to be 4, positive 4, comma, negative 3. B double prime is going to be positive 1, comma, negative 6. C double prime is going to be positive 9, comma, negative 4. Okay, so rotation 180 degrees, whether it's clockwise or counterclockwise, if we look back at the rule, we know is the same. It's negative x, comma, negative y. Okay, so a triple prime is going to be negative 3, comma, negative 4. B triple prime is going to be negative 6, comma, negative 1. C triple prime is going to be negative 4, comma, negative 9. And then rotation about the origin 270 degrees. So again, we have to be very careful with rotations because we have directions, right? So 270 degrees clockwise, if you remember, is actually the same thing as 90 degrees counterclockwise. So it's the same thing as that first rule that we had written. So it's going to be negative y, comma, x. So it's the same as this rule right here. Okay, so anyways, now I have a quadruple prime, and I could just copy down the numbers, negative 4 over 3. B quadruple prime is going to be negative 1, comma 6. C quadruple prime is going to be negative 9, comma 4. So for our last one, rotation about the origin 360 degrees. So we know that that one's very special because a 360 rotation results in the exact same position as to where it started, right? So it's just going to be x, comma y. So A with 1, 2, 3, 4, 5 primes is just going to be at 3, comma 4. B with 5 primes is just going to be at 6, comma 1. And C with 5 primes is just going to be at 4, comma 9. So the rest of the lessons are we do's and you do's, as well as independent practices. Thank you so much for following along in today's lesson, and see you in the next one.